Hello everyone, I am Sarita, currently pursuing my BE in Computer Science from Sri Venkateswara College of Engineering. I am here to explain about embedded system software, which comes under the subject microcontroller and embedded system. So before moving on to the main topic, let us know what is an embedded system. An embedded system is a microcontroller or a microprocessor based system which is designed to perform a specific task. These are programmable and function within a large systems. So these are the examples of a embedded systems. That is the camera, the DVD player, the robotic used in the industries, and many more. So let's move on to the main topic. These are the four typical software components required to control an embedded system. That is the initial code, that is a boot code, device drivers, operating system, and applications. So let's see one by one. Initialization code. From the name itself, we will come to know what is an initialization code. That is, it is the first code executed whenever the device is powered on. It configures the hardware to known state, the memory controller, and the processor caching. It initializes some devices. Boot code is present inside the ROM and is responsible for loading the OS to the RAM, that is, the operating system to the RAM. The initialization code handles three administrative tasks prior to handing over to an operating system image. These administrative tasks can be grouped into three phases. Those are initial hardware configuration, diagnostics, and booting. So let us know these three phases in brief. Initialization hardware configuration normally requires modification to satisfy the requirements of the boot images. For example, the memory system normally requires reorganization of the memory maps. Next is diagnostic code. As from the name, it means as checking. So diagnostic code tests the system by checking if all the hardware components is in working condition. It is a program embedded in the initialization code. The primary purpose of diagnostic code is fault identification and isolation. Next, booting involves loading an operating system image to RAM. Once booted, the system handovers control to the operating system. This is how all the three phases work coordinatingly in initialization code. Next is device driver. This provides a standard interface to peripherals. This lie between an hardware and an operating system. Next is operating system. Operating system provides a common programming environment for the use of hardware resources and infrastructures. It organizes the system resources, that is, the peripherals, memory, and processing times. ARM processor supports over 50 operating systems. Operating system is mainly categorized into two. They are real-time operating system and platform operating system. So what is a real-time operating system? Real-time operating systems provide guaranteed response times to it. It is classified into hard real-time operating system, which is used in hard real-time application that requires a guaranteed response to work at all. Another one is soft real-time operating system, which is used in soft real-time application that requires just a good response time, not a guaranteed response. So here are some examples of real-time operating systems, that is ThreadX, Nucleus OS, VxWorks. Another operating system is a platform operating system. Platform operating system requires a memory management unit to manage large non-real-time applications. It is used in the general purpose computer systems. They use the secondary storage, whereas the real-time operating system they don't use the secondary storage. Examples of real-time operating system. Example of platform operating system are Linux, VCE. Next, these two categories of operating systems are not mutually exclusive. There are operating systems that use an ARM core with memory management unit and have real-time characteristics. ARM has developed a set of processor cores that specially target each category. Next, the fourth component required to control an embedded device is an application. The operating system schedules applications, that is, the code dedicated to handling a particular task. An application implement a processing task. An embedded system can have one active application or several applications running simultaneously. ARM processors are found in numerous market segments, including networking, automotive, mobile, and consumer devices, mass storage, and imaging. Within each segment, ARM processor can be found in multiple applications. For example, the ARM processor is found in networking applications like the home gateways, DSL modems for high speed internet communication, and 802.11 wireless communication, that is the Bluetooth. ARM processors are found in mass storage devices such as hard disk drivers and image products such as inkjet printers, applications that are sensitive and high volume. In contrast, ARM processors are found in applications that require leading edge high performance because these applications tend to be low volume and high cost. But the ARM processors has decided not to focus designs on these types of applications. So this is all about the embedded system software. Thank you.